So I'm going to give you an example of a standard kind of problem that illustrates these two properties that we just had. And it's good practice for composing functions. Verify that f and f inverse are inverses of each other when f of x equals the cube root of the quantity x plus 2 minus 1. So x plus 2 is the radicand. And f inverse of x equals the quantity x plus 1 cubed minus 2. So what you're supposed to do here to verify that these are inverses of each other is to check them in that theorem on the previous video by composing f compose f inverse and show that you get the identity function, which is just, so you'll just get x, f of f compose f inverse of x equals x, and then compose them the other way and see that you get x. Okay. So I'm just going to do first f compose f inverse of x. That's f of f inverse of x. So the inside function is the f inverse. I'm plugging whatever f inverse is into f. So I'm taking this whole thing, and everywhere there's an x over here, I'm plugging that in. Right, so there's only one, and just that one. So I'm plugging this in, substituting this in for that x there. So it's going to be kind of messy looking. Okay? And then you just simplify, and you can see that these always simplify very easily. So you've got a minus 2 plus 2, which cancels, right? Those are inverse functions. So you get, right? And now the x cubed and the cube root of x cancel. And you get x plus 1 minus 1. And then that's just x. Check. Okay, and now you have to take and compose these in the other direction. There are some where if you compose them in one direction, you get x, but you compose them in the other direction, you don't. So you have to do both. So f inverse composed with f of x is f inverse of f of x. So I'm going to take f of x here, and I'm going to stick this quantity in, plug this in, everywhere there's an x over here. Right? It's f inverse of f of x. So I'm going to get this, f inverse of that. So I get, right, I'm not going to say that out loud, it's kind of complicated, but I get that expression there. Now I need to simplify and do the simplest simplification. So, right here, minus 1 plus 1, right? So I'm going to do that one first. And I get this. So now I get the cube root cubed, those cancel, and you get x plus 2 minus 2. And that gives you x. Okay? So that's what you're supposed to do on problems like that. Now, on your homework, you probably can't write all that out, but it is excellent practice for composing and simplifying functions. So I strongly recommend that you do it. The reason it's excellent practice is because you get different kinds of functions that cancel. They cancel fairly easily, so it's good practice for that. And it's good practice for composing, because if you compose them wrong, then things won't cancel right. And you know exactly what you're supposed to get. You're supposed to get x at the end. Okay, that's the end of that section.